Now we want to look at another interesting topic, exponential equation part 1. If you look at the board, what I want to explain now is the foundations, the basic foundation you must have before you can solve any exponential equation. And that is the laws of indices. And the first one there you have a raised to the power x times a raised to the power y is equal to a raised to the power x plus y. What this simply means is that anytime you have an equation of this form and the base of the equations are the same, then you simply add the powers. So if I have something like x raised to the power 4 times x raised to the power 3 is the same thing as x raised to the power 4 plus 3, which is x raised to the power 7. And the second important law you must know before you can solve this kind of equation is that a raised to the power x divided by a raised to the power y is equal to a raised to the power x minus y. In other words, if I have something like x raised to the power 7 divided by x raised to the power 3, it will now give me x raised to the power 7 minus 3, which is x raised to the power 4. And the third one is when you have a situation where you have like a raised to the power minus s. Like I said, this platform is for everybody, so I'll try to use a simple language that everybody can understand. A raised to the power minus s is something as 1 over a raised to the power x. For instance, if I have a number like, let me say I have 3 raised to the power minus 1 is something as 1 over 3. If I have 3x raised to the power minus 2, because of this minus here is an inverse, so I'm going to have, it's called inverse rule, I'm going to have 1 over. Now, this one is also the same thing. This one is because of this minus sign. It's supposed to be power 1, but in mathematics, you don't write power 1, so you leave it. But this one that is minus 2 will be 1 over 3x all raised to the power 2. 3x raised to the power 2 because of this minus 2. Then you can also have a situation like this where you have a raised to the power x over y is equal to the y root of a all raised to the power x. So if I have a number like, let me say 4 raised to the power 1 over 2 is something as square root of 4. You don't write the 2. The 2 ought to be here. All raised to the power 1, but you don't write 1 because 1 is not a power to reckon with. So that means square root of 4, and which is actually 2. But if you have something like 81 raised to the power, let's say 3 over 4 is something as the 4th root of 81 all raised to the power 3, which is actually 3 raised to the power 3, and that will give you 27. Now remember that at this level of education, you don't need to borrow your head too much. With a calculator, you can still just find the 4th root of 81 and it will give you the answer. Now, you might also have a case of x over minus x over y, another case of inverse situation. Now let's take an example. If I have, for instance, 27 raised to the power minus 2 over 3 is something as Because of this minus sign here, I will now say 1 over 27 third root. I'll put the 3 here of 27 all raised to the power 2. And like I said, at this level of education, the calculator is there to help you to tackle this kind of situation. So the calculator will give you 1 over 3 to 27 is actually 3 all raised to the power 2. And final answer will be 1 over 9. Then the last but not the least, we consider before we go to the main equation, which is exponential equation part 1, is a raised to the power 0 is equal to 1, which means any number raised to the power 0 is actually equal to 1. For instance, if I have 3 raised to the power 0 is 1. 7 raised to the power 0 is 1. Now, in solving this kind of equation, I want you to take note of this very important fact. Sometimes the examiners will intentionally write equal to 1 for you. But notice that if 1 is there, you have to look at the basis, the lowest base there in that equation, and convert that 1 to that base raised to the power 0. For instance, if I have something like 3 raised to the power 2 times 9 raised to the power 1 over 2 equal to 1. Now, without wasting time, this 1 here simply means I can change it. It will now become 3 to the power 2 times, sorry, this should be, okay, let's use that. Square root of 9 are equal to 3 raised to the power 0. So what did I convert it to 3 to the power 0 is because the lowest base here is 3. So I will now make it 3 to the power 0, which is also equal to 1. So at the end of the day, what I will have here will be 3 to the power 2 times 3 equal to 3 raised to the power 0. And this 3 here simply means 3 raised to the power 1. Now, without much ado, I can take the powers as my equation. So I will simply, because of this equation sign here, I'll simply cancel this 3, cancel this 3, cancel this 3. I will not take up only 1 3. I will just take up only the powers I have with 1 3. That will give me 3 raised to the power. This one is 3 raised to the power 2 plus 1 equal to 0. Okay? Now, that will give us 3 raised to the power 3 equal to 0. But remember, this is just for illustration's sake. But in normal situation, if you have this kind of situation, they normally put either x or y so that you can be able to find the value of s. Now, let me do a little bit of that so you can understand it. Assuming that I change the equation to, I change it and put a little bit of a letter like x to the power x plus 1 times 9 raised to the power 1 over 2 equal to 1. Now observe that because of this s that is here, the examiner will always ask me to find the value of x. So this one is something as saying 3 raised to the power x plus 1 times square root of 9 equal to 3 raised to the power 0, which is 3 raised to the power x plus 1 times 3 raised to the power 1, because of this 9, is equal to 3 raised to the power 0. Now at this point, you don't need the 3 again, so what you just do is you cancel this 3 and take the powers, which is now x plus 1. Remember that I told you in the law that when you have the same base, you add their powers or their indices. So you add plus 1 equal to 0. That will give us s plus 2 is equal to 0. Then only s is equal to plus 2 because it becomes minus 2. Now, like I said, this is just the foundation where we still need to solve real exponential equations, but I need to lay these foundations very well. So when you start solving, you will not have any challenge. Key points you must take care of when you are solving this kind of equation is the case of decimal points. You might find decimal point appearing as powers. For instance, if you have 0.5, you just know that 0.5 simply means half. That is 1 over 2. Some of you may say, how did you get the 1 over 2? Well, you can do that by just saying 0.5. Since you have only one decimal point here, one decimal point here, and one figure here, you just divide by 0. This 0.5 will now become 5 divided by 10, because you have only one figure here and one decimal point. And 5 here is 1, 5 here is 2. That will give you 1 over 2. Now, if you have something like, let's say, 0.4, it is still the same, okay, let's say 0.2, the same process. If you don't know how to get the answer here, you can just write 0.2 is something as 2. Since you have only one decimal point and one figure here, just divide it by 10. And that invariably will give you 2 here 1, 2 here 5. That is 1 over 5. So that means 0.2 is written as 1 over 5. If you have something like 0.75, you don't need to bother your head too much. The same process works. Just write 0.75 is something as, maybe in a rough paper somewhere, 75. Since you have two values, two numbers here, after the decimal point, just divide by 100. And that will give you 5 divided 75. You have 15. So you have 3. That's 5 divided 75. You have 15. And then 5 divided 100 will give us 20. Then 5 divided 15 is 3. 5 divided 20 definitely is 4. So 0.75 is something as 3 over 4. So like I said, I'm trying to lay the foundation before we jump into exponential equations. Okay, let's look at, we are now moving into this kind of equation on a higher level. We move gradually so that learners can be able to pick it up. Look at this equation. Solve the equation 9 raised to the power 2x minus 3 over 3 raised to the power x plus 3 equal to 1. Now, like I told you, this one here simply means 3 raised to the power 0. And this 9 here, I must bring it to base 3 too before I start solving. So what I will have now will be 3 raised to the power 2 times 2x minus 3 all over 3 raised to the power x plus 3 is equal to 3 raised to the power 0. Now, this definitely will give us 3 raised to the power 4x minus 3. Let me bring it into the common one you understand very well. Divided by 3 raised to the power x plus 3 is equal to 3 raised to the power 0. Now remember I told you something about division when you have common base. Now because it's common base, it simply means that this will subtract, while this will equate to 0. So I will eliminate the 3 because I have a letter here which I'm going to find the value. I'm asked to find the value of this x, this alphabet S. So I'll have 4x minus 3. So the division sign, it now become minus x plus 3 is equal to 0. So these guys are going out. I've taken only the powers. If you look at it, you now have, I'll arrange it properly. So I have 4x minus x. Then I now have minus 3. Remember that there is a minus sign here. And that minus sign that is here is actually multiplying everything that is here. So if I remove this minus sign and solve straight, I'll be getting a very wrong answer because the minus sign that is here is multiplying x plus 3. So what I will have here will be 4x minus 3 minus times s will give us minus s minus times plus 3 will give us minus 3 equal to 0. And then I can now arrange it properly so that I don't make mistakes. So I will now have 4x minus x minus 3 minus 3 equal to 0. That will give us 3x. Then minus 3 is actually minus 6 is equal to 0. So 3s is equal to minus 6 crossing over will become plus 6. To bring out the value of s, you divide both sides by the coefficient of s, which is 3 and 3. And invariably, 3 will divide here, 2, 3 here, 1. So we now know that x is equal to 2. That's the answer of this question, which is also an SSCE question. Now I want to look at another exponential equation that was given to one of the years for the SSCE exams. Now this one is a very simple one, so let's just see how it goes. So you have here, T27 now will become 3 raised to the power 3x times, let me write it so that everything will be in order, times 3 raised to the power 1 minus x all over 3 raised to the power 2 times 2x. Everything now is equal to, remember that this one simply means 3 raised to the power 0. Anytime you see one like that, you will make it to the power 0. And then use the lowest number base there and make it to the power 0, which is 3 in this case. So right now, I will just collect the powers only. And then, but before then, it's good for me to, for the benefit of those people who are just learning for the first time, let me take it step by step. Let me first of all deal with this side of the equation before this. So only this one now is 3x plus 1 minus, and remember that when common base multiply, you add their powers. And when they divide, you subtract their powers. Minus, this thing means 2 times 2s, which is minus 4s. Only this side. Now, everything here now is equal to 0. To avoid confusion, you can as well eliminate them by just cancelling it out. So you have 3x plus 1 minus x minus 4s. Minus because it's dividing is equal to 0. Now let's move the like terms together. So you have 3x minus x minus 4x is equal to plus 1 crossing become minus 1. Then 3x minus x definitely will give us 2x. 2x minus 4x. That will give us minus 2x. I repeat, 3s minus s. Okay, let me write it down for convenience sake. That is 2x minus 4x equal to minus 1. Then this 2s now minus 4x will definitely give us minus 2x is equal to minus 1. So to bring out x, divide both sides by the coefficient of x, which is minus 2. Minus 2. So you find out that s, the minus will cancel out the minus. That will give us s is equal to 1 over 2. X equal to 1 over 2. That is one of the SSC questions. I want you to hit that substitution button, and you have more of this even in our next series.